Alright, so hello and welcome. Apologize for that. Actually, that was the wrong problem. That was someone had asked for Java, and I assumed that I could solve that in Java, but that was actually SQL only question. That was an SQL only question, so forgive me for that. We're going to go ahead and take a look at the design circular deck question on LeetCode. Give that a shot. Try to do this in Java rather than C++, as per request. Oh, that's interesting. Yes. So, design your implementation of the circular double-ended queue deck. Implement the myCircularDeck class, myCircularDeck int k. Initialize the deck with a maximum size of k. Boolean insert front adds an item at the front of deck, returns true if this operation is successful or false otherwise. Boolean insert last adds an item at the rear of deck, returns true if the operation is successful or false otherwise. And Boolean delete front deletes an item from the front of the deck, returns true if the operation is successful or false otherwise. Delete last, Boolean delete last, deletes an item from the rear of the deck, returns true if the operation is successful or false otherwise. Int get front returns the front item from the deck, returns -1 if the deck is empty. Get rear returns the last item from the deck, returns -1 if the deck is empty, returns true if the deck is empty or false otherwise. Boolean is full returns true if the deck is full or false otherwise. I mean, this is kind of interesting. There is already a deck object in Java. I'm not really sure exactly what they want. Do they want us to build it from the beginning? Because you can use a deck, in my opinion, a doubly linked list is the way to do it. And then just append and remove elements from your doubly linked list. Which actually I think even Java has both, I'm pretty sure. Java has a deck class and also a doubly linked list class. So we could kind of do either one, I guess. Aren't really many constraints. I don't know, I'm kind of wondering what the discussion says, because this could be like, this isn't a particularly hard question. This is just sort of like one of 3 different options you could pick. One, you could basically implement your own doubly linked list class, and then use that for your to implement your deck. I guess actually this isn't just a deck, this is a circular deck. So I guess we could use our deck class as well. I should take that back. But there's also, yeah, I'm sorry, I take it back. This I actually think this is exactly what it's supposed to be, where you're actually allowed to use either the linked list or the deck. For some reason, I misunderstood that this is not just a circular deck, but not just a deck, but a circular deck. So that's my mistake. So maybe we can just use those other data structures. I take it back. But yeah, you can go like deeper in this question if you wanted to. So you can implement the other pieces. So initializes the, okay, so what's the circular part though? It seems as though insert front, insert last, delete front, delete last, get front, get rear, is empty, is full. This kind of just seems like a regular deck. I don't know. Implementation of the circular double-ended queue deck. Implement the circular deck. Initialize the deck with a maximum size k. Insert front, adds item to the front, returns true. The rear returns true, deletes item from the front. Excuse me. Returns true, deletes item from the rear, returns true. Turns the front item from the deck. I mean, I don't really know what to say here. It's empty, get rear, get front, it's full. I'm very confused actually by this. There's nothing really circular about this. Why did this get so many upvotes? Downvote it. Downvote it. How are we doing? Time. 4 or 5 minutes already? Okay. New 3, insert last, return true, return true, return true. False, queue is full. Okay. So I guess if it's full, Then you can't add any more. Get rear is 2. Is full is true. Delete last true. Insert front true. Get front 4. Excuse me. I don't know about this, man. I don't think this is... There's nothing circular about this. Like, this is just a double-ended queue. I think. I'm a little confused. Yeah. Huh. I don't know, man. This just seems like a double-ended queue. I don't know what makes it circular. I guess we could just use a double-ended queue. I don't know. Yeah, Java has a double-ended queue class. We can just use that. I don't know. I don't know what to say. Well, you should check the discussion afterwards to get an idea. Move to another question. Yeah, I think you're right. Yeah, that's a good call. Let's implement this one just quickly, just so that we have some review of double-ended queues. I agree with you. Of their functionality, so we have a little bit of review. But you're right, we should do another question. That's true. That's true. All right. So Deque, add, get first, get last. Yeah, I mean, these are basically just Deque operations. There is something to be said about the size, though. The number of elements is not the same thing as the capacity of the Deque, which is interesting. So I guess this is sort of like a limited capacity Deque. Maybe that's a little bit of functionality that we're adding. All right. So we're just going to wrap a Deque with a little bit of extra code. I think that's what we're going to do. We want to... Yeah, we add first, add last, remove first, remove last. If get first, get last, we can use also for peaking. Offer... there is capacity restrictions. Okay, that's actually what we'd want to use. So I guess we're really not wrapping very much then. There's already code for all this. Yes, it's just a Deque. But how do we get the capacity though? There's got to be a constructor, right? This is really just a Deque. Where's the constructors? Where are the constructors? Is this? It's an interface. Excuse me. So I guess array Deque is what we want. Do you want array Deque or linked list? Yeah, this really is just the Deque object. So please forgive me if this seems kind of awkward, I guess. What I'm about to do here. Linked list. Oh, okay, neat. So it is a Deque. Okay. So I could use either array queue or I think array queue is what we want. Yeah, we really should just do another number. I mean, we'll go through it, what it might look like to do this. But it really is just the array Deque is what you would use here. Okay. We're going to get a little more familiar with I guess just the array Deque class. So we can say we want our array Deque and we want to include it as well. So import. And it's been a while since I've solved anything with Java. So thank you for asking me to do so as well. So Java util. All right, we'll just say java.util. We should have array Deque. That's all we need. We don't need the whole. Don't need the whole thing for all of the utilities. Oops. Array Deque. All right, private array Deque, and we're going to use generics. Use integers. No, actually, it would be integers, and say array Deque. And we do want to use camel case for Java for the most part. Okay. We'll say array Deque equals new array Deque of integers. We're using our constructor here, so we also want to specify k. Right, now something very subtle here is this is a whole class, so if you use negative values here, you would have exceptions, right? So this really should be like an unsigned integer, something like that. But we're going to assume how we're using things that we don't need to like basically guard our inputs. So inserting in the front, array Deque is, so I think we need to use offer for all of these routines. Interesting, okay, so insert the element at the end, but it'll return false if we don't actually offer first, offer last. Okay, so offer first is what we want. All right. Same thing here. So this isn't really a great problem, but this is okay, I guess. Delete first. So we want to go to Deque. It's okay. Remove first or pull first? I think it's pull. No. We want to remove, but we also want to return true or false if it's successful. And we're actually gonna, it's actually a pop. It's potentially pop. So that's interesting. Really it'd be, so this is slightly different. The remove first would be, you could peek, pop. I think you do need to peek and pop. It's not really peek, it's really just if it's empty. So we could just say pop. So we'll say remove first if peek first. It's not really peek first, it's more so just plain old if there is something in the Deque, if it's not empty. So there's an is empty somewhere here, yeah. Okay, so if not is empty, so let's do that. So if is empty of array Deque, turn false, otherwise array Deque dot remove first, turn true. And the same thing over here as well for the back. And yes, capacity restricted. So get front, get rear. -1 of the Deque is empty. So let's see. Close some of these. Okay, I guess just get first, get last. Null if the deck is empty. Peek first, peek last. I kind of prefer that, I think. Sure. So array peek first, we'll say if array peek first. Now I think in Java you have dot equals. I think you actually, you can do it this way. So int ret, integer ret. Let's return ret. Okay. That's for the front. That's for the back. Same thing. And is full. So I guess we could save the capacity here. I don't know if there's a way to grab the capacity from it to the array deck. Oh, I see. The array decks don't have capacity restrictions, so we need to enforce that, I think. So actually, oh no, I see. What's interesting is, so actually, this offer is not really what we want. It actually doesn't work for the array deck. Not the way that we want it to. Oh no. I guess this is a good exercise to look at. Spend the time thinking about these things. How are we doing? 17 and a half? 18 minutes now? Okay. Yeah, so the offer part doesn't really matter for this deck. Yeah, we actually need to add that logic here. So we would say if array deck dot size is less than k, we have to actually size equals, I guess it'd be 0 initially, you could just say, and then we'll say array size equals k, and then we'll say as long as our size is less than k, then we can offer. Oops. Hold on. Oh, okay, hold on. Array size is less than, or array deck dot size is less than k. And then we would offer. That pretty much always works. I mean, you could really just insert first then. Push first. We don't really have to offer. Add first. Yeah, say add first now. And the same thing here. Oops. Yeah, so it's not particularly hard. But you do need to wrap that a little bit, I think. What else? Q. Same thing. Should probably name that better than ARR size, array size. All right, let's go for it. I don't know if this is going to be correct. I feel like there's probably some edge case I'm missing. Probably. I didn't really think about this enough. Oh, I got it. Okay. Yeah, I mean, I don't know. This is like, you could write your own you could write your own doubly linked list class and then implement this with that. This is like, but why spend all that time doing that if you don't need to? So, all right, we'll do another question in Java as requested, because this question was kind of like, you know, kind of, I don't know about this question. So, oh yeah, so thank you for watching, and we'll go to another question shortly.